This section is on nonlinear inequalities. Inequalities is a word that you've seen before. Okay, this is anytime you have, for example, x plus 3 is greater than 7, and we would solve it, and in algebra 1 and algebra 2 or intermediate. The difference here is that they're going to be nonlinear. It means the equations, the inequalities we're going to solve are going to they're not going to be linear. So they're going to be, like quadratic, x squared and x cubed, and, so a little bit more complicated. So an inequality, right, will look something like, for example, this, not f of x, but suppose, you have something like this, x squared minus 5x plus 6. This is like my go-to equation. And, greater than 0. Yeah. So that's an example of a nonlinear inequality. So what's different is, instead of this being equal to 0, it now says it's greater than 0, right? Now it could say greater than 0, less than 0, greater than or equal to 0, less than or equal to 0, right? So they're written in this form right here. Okay. Well, what does that mean? Well, if you were to graph an equation, all right, if you were to graph that expression or some other expression which is graphed here, this is a more complicated expression, right? Something of a higher degree. What does it mean for the function to be greater than 0 or less than 0? Well, greater than 0, what are your numbers greater than 0? Like 1, 2, 3, 4. What are your numbers less than 0? Negative 1, 2, 3. Exactly. So when we say greater than 0, we mean the positive numbers. When we say less than 0, we're talking about the negative numbers. Okay? So if we have a function that says, f of x is greater than 0, we want the function to be positive. When you have a graph, what does it mean for a graph to be positive and negative? Well, here is the x-axis, right? Anything vertically above the x-axis is where f of x is positive. So all of those is f of x greater than 0, positive. All the times where the function is below the x-axis is where f of x is negative. So here, f of x is negative. So that's what it means conceptually. When we say f of x is greater than 0, what really we mean is if we graph it, that portion of the graph is going to lie above the x-axis. Okay? All right. Let's get into more practical things. What does that mean for us? Well, to solve a polynomial inequality, we're going to solve f of x. We're going to plot the zeros on the number line, and we create what is called a sign chart, one of my favorite things in the world. And then we test values from each interval. Okay? It sounds like gibberish, but we're going to do one, and then we're going to do another one, and then each time you have to do it, you just have to stick to step 1, 2, 3. It's going to be the same steps every time. Okay, so let's do one. Here, let's bring the 1 over so that this is less than or equal to 0. Right, so I'm going to subtract 1 from both sides. So it's going to be x squared minus 8x plus 15 less than or equal to 0. Now I'm going to treat this just like an equation where it said like equal to 0. So here I factor, right? We're experts at factoring. How does that factor? Fantastic. So from that, we get x equals 3 and x equals 5. So that was step 1. We solved f of x. Step 2 is plot zeros on a number line to create a sign chart. Okay, question. Maya question, yeah.
What's the rule that, like, if you subtract something from one side, then it's what?
Oh, no, it's if you divide or multiply. So here, this is a number line. We're going to put 3 and 5 here because I've said plot zeros on a number line. We did that. To create a sign chart. So that's what we just did here. Now we're on to step number 3. Test values from each interval. Okay, look at the number line. How many regions is that number line divided into right now? 3 regions. We have the one on the left, middle, right. So look at the region on the left. Okay, what numbers are in that region? What's a number from that region? 2, 0, all of those. -5. So there is like an infinite number of numbers there. You have to pick a number from that region. You could pick -3,456. You could pick 1. My favorite is 0. Okay? So let's pick a number from that region. So from that region, suppose I pick 0. Okay? I'm going to plug it into my equation here. Okay? So here, plug into this. So I plug 0 in there, and all I care about is that I'm going to get a positive or a negative number. Now, let me show you what's even easier is if you plug it into this. Okay? The factored form. So if I put 0 for x here, for x minus 3, I get negative, right? How about for x minus 5? Negative. Negative times negative makes positive. So here, that means when I have x equals 0, I get positive. The actual number does not matter. The actual value, I don't care about. All I care about is, if I were to put x equals 0 into this equation, is the result going to be positive or negative? Okay? Question here.
Are you plugging 0 into x?
Yeah.
If that isn't just 0.
Huh?
Isn't it just 0?
It'll be 0 minus 3.
And then you multiply.
Right. So let's write it down. So I'm plugging it into here. X minus 3. X minus 5, right? So if I put 0 in there, I get 0 minus 3, 0 minus 5, right? Negative times negative, that makes positive. Okay, now let's pick another number from the middle region. Give me a number from the middle region. 4 sounds good. So let's put 4 in here. 4 minus 3, 4 minus 5. What do you think? Positive, negative, together they make negative. Let's pick a number from the very last region. 6 sounds good. 6 minus 3, 6 minus 5. What do you think? Positive, positive, positive. Okay? Now, initially, our equation said x squared minus 8x plus 15 is less than or equal to 0. Is that positive or negative? Positive. Less than or equal to? Negative. Okay? So here we want the negative region. In this number chart, a sign chart, the middle region is where I got negatives, right? So my solution is in this middle region. Okay? So my answer is the region between 3 to 5. So I say 3 to x to 5. Okay? All right. And then one thing to watch out for. If it's less than or equal to, I put less than or equal to. If it was like less than, then I would have just put less than, right? If it didn't have the equal to. We'll see more of that in the next problem. So let's do one more. And then, you know, hopefully things will solidify a little bit more. Yes. So here, I'm going to bring everything to the left side, and it's going to be x cubed minus 3x squared minus 22x. Yeah. You add or subtract. Okay. Does that work? Okay. Now I need to solve that. Well, how do I solve it? I either factor or this, you can't factor. What are we going to do?
Can you divide?
Huh? But is this a quadratic equation? It's x cubed.
Can you divide?
So this you can't factor by grouping. It's not possible to factor by grouping. It's not. Because P over Q.
Oh, that's the answer. Oh, no.
P over Q. So we're going to do P over Q, okay? Now look, I'm going to give you a cute little shortcut to do here. Okay? So let's graph this because that's what we were normally doing. X cubed. Oopsies. Minus 3x squared minus 22x plus 24, zoom 6. Okay, what's one that works here? It looks like -4 works, right? So let's see, trace -4. Yeah, that works. All right, so I'm even going to skip the part about writing the P over Q's, right? So let's see. Let's go with -4. And yeah. Remember how we used to do P over Q and then instead of, you know, doing, we just picked one? All right, so 3, -12, -15, 60, right? And then what? What do we get here?
Wait, why is it? Wait, yeah, it should be 1. Wait, yeah, isn't it 1?
Oh, this should be 1. I'm sorry. Okay, so we get 1, -4, -7, 28, 6, -24, 0. All right, so what do I have here? X plus 4. X squared minus 7x plus 6 is greater than 0, right? We're going to keep it. And then let's factor this. We're done with the calculator. So we get x plus 4, x minus 6, x minus 1, greater than 0. Okay? You guys, huh? Right. So now, in my number line, what numbers am I going to put?
4, -6,
-4, -6, and 4, the opposite. -4, +6, and 1, right? So from here I get x equals 4, 6, and 1. -4, 6, and 1. So -4, 1, 6. Put it in number, you know, proper order. All right, so now I have how many regions?
5.
4, right? 1, 2, 3, 4 regions. Okay, I'm going to plug them into this x plus 4, x minus 6, x minus 1. All right, so what number from the very left would you like to plug in?
0.
Well, from the very left,
-5.
it would be -5. All right, so in the first parenthesis, that gives me -1. Right, so let's do this. Right, so we get negative in the first parenthesis. In the second parenthesis, I get negative. Right, and then in the last one, I got negative. So together, negative, 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 that makes negative. I picked -5 from that region. Now, from the, Now you have to pick one from the second region. So in region 2, 0 is the best. So in the first parenthesis, that gives me positive, then negative, then negative. Together, that makes positive. In the third region, I'm going to pick, I already picked 2, I'm sorry. So 2 plus 4, that's positive. 2 minus 6, that's negative. 2 minus 1, that's positive. Together, that makes negative. And then I'm going to, and then I'm going to pick, all right, you guys. 7. So 7 in the first parenthesis gives me positive. In the second one gives me positive. And the third one gives me positive. So that's positive. Okay, now, the question I'm asked is greater than 0. Is that positive or negative? Positive. So I'm going to pick this region and that region. So now I have 2. From the first region, I get -4 less than x less than 1, right? Because this is between -4 and 1. Here, what are all these numbers? It's all the numbers greater than 6. So I just say x is greater than 6. X is greater than 6. And those are my answers. Okay? Now I'm going to share a couple of secrets with you. Well, one secret. Oh, before I take your question, so notice in this case, the inequality was just greater than. It doesn't have the equal to. So in your answer, you don't put the equal to. Okay? Yes.
So what you do with the -4 and 1 that you got rid of it? Oh no, that's part of the answer.
Right, that is the answer. So because I got a positive in this region, and the question was asking for like greater than 0, then it's going to be, all the numbers between -4 and 1. -4 less than x less than 1. Okay, now here is a little secret. Don't tell anybody this. Okay? Okay? Now, when you factor it like this and you get them in like parentheses, okay? Take a look at this parenthesis. It's x minus 3 exponent 1. Look, it's like x minus 3, there is no exponent, so it's like exponent 1. X minus 5 exponent 1. Versus if it said, for example, x minus 3 squared. Do you see what I mean?
Imaginary 1 exponent.
Right. Okay. If that's the case, the signs here are always going to alternate. So all you have to do is find 1, and I usually pick the one where the 0 is. So like here, I would have picked this one, 0, got plus here, and then do minus plus minus plus. They're always going to alternate. Okay, moving on, you know that for every rule there must be some exceptions. So let's take a look at these then. Same situation, we're going to factor this. Although, you take a look at this and you go, okay, not possible to factor. So then I have to use the quadratic formula to find a 0. Okay? Doesn't factor. So let's use the quadratic formula. X equals -b plus or minus the square root of b squared minus 4 times a times c all over 2a. X equals -2 plus or minus the square root. 4 minus 12 is -8 all over 2. And what happened? -2 plus or minus, you have an I. 2i root 2 over 2. What does that mean? If the root is imaginary, where does the graph cross the x-axis? It does not cross the x-axis. Now, look at the equation there. It's a quadratic equation. So what would its graph look like? What shape would its graph have? It would be a parabola. If it doesn't cross the x-axis, so here we go. Let's write this down. Imaginary solution, which means does not cross x-axis. Okay, so what kind of a graph is it if it doesn't cross the x-axis? Well, it's a parabola that's lying above the x-axis. Or it could be below. This one happens to be lying above. Well, because all the numbers are positive, that sort of tells me that it's above. So, okay, listen. So here's what you are going to do. Okay, here's what you're going to do. I still do my number line because, okay, how do I know if it's positive or negative? Now, if it's a number line, it's got to have some numbers on there. And what's my favorite number? 0. So I just put 0 just to, have it like, grounded. Now, let's pick a number less than 0. How about, -1? So notice, if I put -1 in here, okay, I'm going to get 1 minus 2 plus 3. It's going to be positive. Okay? What if I put a positive number in there, like 1? It's going to be 1 squared plus 2 times 1 plus 3. Positive or negative?
Negative.
If I put 1 into x, 1 squared plus 1, it's positive, right? What if I put 0 in there? Positive. So it's positive everywhere. Okay? What is the question asking? The question is asking where is it less than 0, which is negative. It's nowhere, so it's no solution.
So is it whenever there's an imaginary, it's no solution or no? Whenever there's an imaginary,
No, it's the next one. No, it's whenever there's
whenever it's like all
because they're all positive, but in the original there's less than 0, and none of them are less than. If it's like greater than 0, then there would be a solution.
Okay, so look at the next one. Same function. Now it's asking where is it greater than or equal to 0. So it's the same equation. Okay, same number line. Okay, this is what we had before, positive, positive, positive. Now I'm being asked, where is it greater than 0 or where is it equal to 0? Everywhere, all real numbers. So the solution here is all real numbers. You can just do the symbol. Okay? All right? I know. Okay, let's factor this guy. This is another special case. Okay? Let's factor this guy. Can we factor him?
Yeah.
We can.
X plus 7. I mean X plus 6.
X plus 6, X plus 6. So that's like the middle school way of writing it. We like to write it x plus 6 squared less than or equal to 0. So what x do we get from that to put on the number line? -6. So let's pick 0. Does that lie on the left or the right? The right. When you put 0 in here, you get positive number squared and you get positive. What if you put a negative number?
Negative. Oh, it's positive, right?
It's positive again because it's going to be squared. So one way to look at it is no matter what I put in here, eventually it's going to be squared. So it's going to be positive everywhere. Well, let's see. Well, okay, hang on. What is it asking? It's asking where is it less than or equal to 0. Okay, so hang on. When you put in -6, what's the answer? 0. So at -6, you get 0. Okay. Hang on. This is my favorite one so far. It's asking, where is it less than or equal to 0. Normally when we say that, we say it as if it's like one word, less than or equal to 0.
No, it's infinite.
Okay. What it's asking is, where is it less than 0 or equal to 0? So there are two criteria. Okay, so where is it less than 0? Let's just take care of that part. Where is it less than 0? Nowhere. Where is it equal to 0? At -6. So the answer is only -6.
But it's asking where it's less than 0, right?
No. It's asking where is it less than or equal to 0?
So wouldn't it be less than or equal to 0 if it was -6 or below?
No. So it's saying less than or equal to 0. Okay, it's less than 0, never. It's equal to 0 at x equals -6. So that's what I was saying before, is when we say less than or equal to or greater than, you just say it like it's one word, greater than or equal to 0. But it's not. Greater than 0 or equal to 0. It's like you have two chances to apply to like the lottery, right? You have to be, less than 20 years old, or you have to be like 23 years old or something. You know what I mean? Like you have two chances. Okay. Let's just, if you have rational inequalities, all right? Rational means like fraction. So if you have an equation that involves a fraction, the one thing you have to watch out for is you have to look at the zeros, and you have to look at the zeros of its denominator. This should say denominator. Okay? So we're going to solve it, and just like we did in section 2, but then in the end we're also going to include the denominator. All right? So let's just solve this the way we solved it in section 2. What is the LCD? Okay, so we're going to get 3x plus 4 is greater than or equal to 0 times that is just 0. 3x is greater than or equal to -4. X is greater than or equal to -4/3. So now here's what we do. I'm going to put -4/3 on the number line. But I also take the denominator. So set denominator equal to 0. X plus 2 is equal to 0. What do I get? X equals -2. I also have to put that here. That's the extra step. It makes all the difference. I'm telling you from now. All right? How do I know where to put this? How did I know to put it to the left or to the right? Well, what's 4/3? It's 1 1/3. So it's like 1.3. So it has to go further to the left. Okay? Yeah.
I'm kind of confused when you were translating them, you did x+2, but we didn't multiply the other x.
Right, because it was 0 times x plus 2 here, which is 0. So let's pick a region. Let's pick from the very right this time. Let's pick x equals 0. Okay, so we're going to plug into this equation. Okay, so if x equals 0, I'm going to get 4/2, which is positive. So here I get positive. Huh? Yeah, so what if we do like the left now, the very left, like -5? Okay, -3. Let's do -3. We're going to get -9 plus 4, so that's a negative number on top over a negative number on the bottom. So that's going to be positive. Now take a look here. There is no parentheses and raised to an even power. There is no parentheses and raised to an even power. They're going to alternate. So it's going to be plus minus plus. Okay? Now, what are we being asked for? Greater than. So is that positive or negative?
Greater than or equal to.
Positive. Well, it's just, greater than or equal to. Thank you. Yeah. So positive, that means I'm going to take which regions? The left and the right. So on the very left, it's all the numbers less than or equal to -2. And on the right, it's all the numbers greater than or equal to -4/3. Ugh. So this next one is a fraction less than or equal to 3. I give this advice every single time, and often students forget to take my advice. Here's my advice, and then they get into, like, they run into trouble. Here's my advice. Before you even do anything else, take everything to the left side of the inequality. All right, so that means this is going to be x squared minus x minus 11 all over x minus 2 minus 3 less than or equal to 0. Now that's going to be what we're going to work with. Okay, what's the LCD? X minus 2. So let's multiply everything by x minus 2. Okay, here x minus 2's cancel. And we have x squared minus x minus 11 minus 3 times x minus 2 less than or equal to what? 0. So x squared minus x minus 11 minus 3x plus or minus 6 plus 6 less than or equal to 0. Let's combine like terms. X squared
Minus 4.
Minus 5, is it?
Yeah.
Oh, we can factor. X minus 5, x plus 1. Okay? All right, so what numbers do we get from the first one? 5, -1. So on my number line, I'm going to put -1. Oh, that's not -1. -1. 5, and what else?
3.
From the denominator, 2. I know.
So you use the LCD also.
Yes. So this from the denominator. Don't neglect that denominator. It's special. Okay? So take a look. X minus 5, parentheses, x1 at 1, x plus 1, parentheses, x1 at 1. X minus 2 doesn't have an exponent of, an even exponent. So they're all going to alternate, right? So let's pick 0. Which region is 0 from? The second one. So let's pick 0, and we're going to plug it into this one, x squared minus x minus 11 over x minus 2.
You wouldn't use the factor then?
No, because you want to plug it into like one of the originals, because you want to take the denominator as well. So let's pick x equals 0.
But didn't you say this one's easier to plug into the already the
Yeah, but those weren't the rational functions. Those weren't the ones with the denominators. Yeah, those were one of these. All right, here, when I put 0 into the numerator, I get -11 over -2 minus 3. So we are going to have to do some math here, unfortunately. 11 over 2, that's like 5 something, minus 3, we're going to end up with positive. So if that's positive, they're going to alternate. We're looking for less than, so that's the region on the left and the middle. So we get, and, right, 2 is less than or equal to x, less than or equal to 5. Yeah, before I do that, let me say that this homework will be due the next time that I see you, which is Tuesday. Tuesday is also turn in your homework day, so we're collecting 2.2 and 2.3. Okay, fantastic.